In this video, we will explore the primary tools used for developing virtual reality applications. Just a disclaimer, the field of virtual reality is constantly evolving. Here, I will introduce some of the main tools commonly employed in virtual reality development. It's possible that I may overlook certain important tools, or you may have a different perspective. I am to highlight the most popular tools at this particular moment, and it's highly likely that significant changes will occur in the upcoming months. I apologize if I have omitted anything essential. While this is a model focused on virtual reality, I will begin discussing graphics libraries. In the early days of computer graphics, there was no standardized approach, and each research group or manufacturing company created their own platform. Over time, things started to stabilize. OpenGL emerged as the first de facto standard for computer graphics. OpenGL passed through several upgrades that resulted in something quite different from the original version, but it remains a standard. Today, Vulkan is gaining prominence, replacing OpenGL. Vulkan is a very low-level API designed to be cross-platform. Microsoft introduced DirectX and Direct3D for graphics, which are widely used on the Windows platform. Apple, on the other hand, developed its own platform called Metal. It's highly likely that you are using right now one of these API for graphics rendering. Now, when it comes to web-based graphics, we have WebGL, which has broad support in current web browsers. Users can use this low-level instruction set within their HTML code to create web-based graphics experiences. As new head-mounted displays began to emerge, each manufacturer created its own low-level API for their virtual reality development kit. This resulted in a multitude of APIs, each distinctive from the other, which make life difficult for developers. For example, Oculus had its own API. Valve developed OpenVR for the HTC Vive headsets. Magic Leap has its specific API, and Microsoft introduced the WMR, among others. To address this fragmentation, the Khronos Group proposed OpenXR, an open and royalty-free standard for accessing virtual reality and augmented reality platforms and devices. Today, OpenXR has become a reality, and virtually all major virtual reality companies have transitioned to some extent to support OpenXR. This means that developers can now use OpenXR API to create software that runs on multiple platforms, simplifying the development process and increasing compatibility. Here's a text describing OpenXR. OpenXR is a royalty-free open standard that provides high-performance access to augmented reality (AR) and virtual reality (VR), collectively known as XR, platforms and devices. As depicted in this image from the Khronos Group, OpenXR serves as a connector that provides a straightforward channel for linking applications with VR devices. One of OpenXR's noteworthy features is its support for extensions and API layers, allowing integration with potential new resources or functionalities. Furthermore, when it comes to game engine, major game engines have already added support for OpenXR. The concept is that you can develop your application, or more specifically, your code, and utilize the OpenXR API to access the virtual reality resource you require in any device. So, you need an OpenXR runtime, which is capable of interpreting OpenXR commands and parameters and executing them on the desired VR device. Companies like Steam or Oculus provide programs that serve as OpenXR runtimes for their device and partners' platforms. In addition to these commercial solutions, there is also Monado, an open source project. Monado is OpenXR compliant and supports a range of devices. It is particularly geared toward Linux, which is significant since most virtual reality solutions are primarily designed for Windows. Monado can serve as a valuable reference for individuals interested in creating their own OpenXR runtimes. The next low-level API I would like to bring here is for the mobile devices. The two big companies, Google and Apple, create their own AR solutions, and most of developers move to that. I'm talking about ARCore that is used in the Android devices and ARKit that is used in iOS devices. They are aiming to the same goal for augmented reality, but the APIs are different and by consequence not compatible. These APIs have many resources for AR, like identifying the environment, tracking, mixing virtual with the real images, beside many other resources. But having two standards is not something convenient. In the case you are using Unreal Engine or Unity, you have access to integration tools that allow you to develop for augmented reality in a neutral API and deploy your application on various platforms, greatly simplifying the developer's workflow. Unity refers to its AR platform as AR Foundation, which incorporates core features from ARKit, ARCore, and more, make it a comprehensive solution for augmented reality development. Unreal Engine offers a similar framework for augmented reality, which you can explore through the handheld AR template. Additionally, there is a third option worth mentioning, which is Vuforia. Vuforia is a commercial solution that's quite popular. You can develop applications using the Vuforia API on both Unity and Unreal Engine, enabling you to after deploy your applications on a wide range of platforms. Continuing with low-level development, but this time for the web, we have WebXR. WebXR is akin to WebGL, serving as a low-level API that modern web browsers can interpret to execute commands. WebXR is specifically designed for augmented and virtual reality instructions, which is the browsers can utilize to communicate with the head-mount display, for instance. The concept behind WebXR is to provide support for augmented and virtual reality, with the graphics still being generated by WebGL. These two technologies work in tandem to deliver immersive experiences. WebXR is a well-documented standard widely embraced by the development community. If you're planning to develop graphics for the web, well, WebGL may be a little challenging, especially if you are new to computer graphics or virtual reality. In this case, I recommend using a higher level API. The two most renowned high-level APIs for web graphics are Three.js and Babylon.js. These two libraries differ in their features and capabilities, so your choice should align with your specific project goals. However, it's worth noting that both Three.js and Babylon.js are built on top of WebGL and offer support to WebXR. Therefore, if you intend to create virtual reality applications for the web, you can utilize either of these platforms directly, simplifying the development process. It's important to mention X3D, which is an open standard for virtual reality on the web for defining VR worlds. X3D is typically encoded in XML and allows developers to define 3D objects, audio, object behavior, and other essential resources for virtual reality experiences. X3D files are easy to read and modify, and they offer portability across various platforms. The X3D and VRML specifications are maintained by the Web3D consortium. If you plan to use X3D for web-based virtual reality development, you need JavaScript code to execute your X3D files. There are two main JavaScript libraries you can use directly in your HTML file for this purpose, Xite and Xfreedom. Integrating either of them is straightforward. You simply call the JavaScript library and point it to your X3D file. Additionally, there's A-Frame, which represents a newer standard. A-Frame allows you to write virtual reality codes directly in the HTML document, and its integration is as simple as calling its JavaScript library. While A-Frame has a different syntax compared to X3D, it offers convenience and flexibility. Furthermore, it's worth noting that these platforms are moving in the direction of supporting the WebXR API, making it easier for developers to create immersive web-based virtual reality experiences. If you prefer to develop virtual reality applications on native platforms using C++ code, you have options like FlowVR, VRJuggler, or Avango, among others. However, it's important to note that most of these traditional platforms may not support OpenXR, which can be a limitation if you plan to connect with the modern VR headset that utilize OpenXR. Nevertheless, these platforms can still serve as reference points and may be suitable for specific use cases or projects that don't require OpenXR compatibility. The most common and versatile approach for developing virtual or augmented reality applications in the current landscapes is through game engines. There are three main game engines that are widely used for creating XR applications. Unreal Engine offers powerful tools and capabilities for developing immersive XR experiences. It's known for its stunning graphics, real-time rendering, and support for a wide range of platforms. Unity is another highly popular game engine that's extensively used for XR development. It offers a user-friendly interface, a vast library of assets and plugins, and cross-platform compatibility. Godot is an open-source game engine that has gained significant traction in recent years. It has evolved into a capable platform for developing XR applications and benefits from an active community of developers and contributors. Godot offers a unique approach to game developers, and it's suitable for those who prefer open-source solutions. These game engines are incredibly flexible, allowing developers to explore modern graphics and interaction techniques for creating immersive XR experiences. They offer the flexibility to build applications for native platforms like Windows, Mac, or Linux, as well as for the web or standalone headsets. The approach of using game engines for XR is currently the most widely adopted strategy. When developing within a game engine for XR applications, it's common to utilize toolkits or interaction SDKs instead of programming directly with low-level APIs like OpenXR. These toolkits are designed to integrate seamlessly into game engines and simplify the development process by providing pre-built mechanisms that are traditionally used in XR applications, like object manipulation, locomotion through the scene, and UI interactions. Many major companies offer toolkits for the main game engines, but you can also leverage the game engine's built-in toolkits for XR development. For instance, Unity offers the XR Interaction Toolkit, which is a powerful set of tools for creating interactive experiences in VR and AR, and it's designed to work seamless with the Unity environment. Unreal Engine offers an OpenXR extension plugin, which simplifies XR development. This plugin provides features for creating immersive XR interactions and experiences directly within Unreal Engine. Godot has also a toolkit for developing XR applications. These toolkits and plugins streamline the development process, making it more accessible for developers to implement common XR interactions and mechanisms within their projects. They help reduce the complexity of coding XR interactions from scratch, allowing developers to focus on creating compelling XR experiences. Certainly, another option for developing virtual reality experiences is through final applications or metaverse platforms, where you can load scenes and create immersive environments. The landscape for metaverse platforms is rapidly evolving, and it's challenging to provide a list of possibilities due to the ever-changing nature of this space. However, I can rely on a platform as an example, the News Metaverse platform. In News, you have the opportunity to create your virtual world and program within it using resources like the Logix. This platform can serve as a good starting point if you are interested in developing virtual worlds with a high degree of control and customization. Metaverse platforms like Neos offer a unique and dynamic environment for VR development, enabling you to build interactive and immersive experiences within shared virtual spaces. As the metaverse ecosystem continues to evolve, more opportunities for creative VR development are likely to emerge. It's worth mentioning Elixir, an open XR runtime developed at the University of Illinois. Elixir serves as an open-source OpenXR runtime implementation with open access to benchmarking. Its primary objective is to be a community references and open-source testbed, offering a benchmarking methodology for XR researchers. Elixir plays a valuable role in providing a standardized platform for testing and evaluating XR systems. As the XR landscapes continue to evolve, initiatives like Elixir can help researchers and developers to access and optimize the performance of their XR solutions. In summary, when embarking on development of a virtual or augmented reality application, consider the following key factors. API level. Decide whether you develop using a low-level or high-level API. High-level APIs often offer easier development but might have limitations, while low-level APIs provide more control but require great expertise. Target platform. Consider the target platform. PCs offer higher graphics quality and resources, and standalone devices may require resources optimizations. Choose the platform that aligns with your project's goals. Execution. Choose between native or web applications. Native applications offer more control over devices' resources, while web applications are becoming more flexible and accessible over time. Game engines. Consider using a game engine for streamlined development. Popular options include Unity and Unreal Engine and the open source Godot engine. These engines provide tools for creating XR experiences effectively. Metaverse platforms. Explore metaverse platforms like Neos for creating virtual worlds and experiences within a shared environment.